The Fibonacci sequence in the sequence of integers 0, 1, 1, 2, 3, 5, 8, 13, 21, 54. ఇది ఫిబొనాసీ సిరీస్. పైన ఉండేది ఆడ్ సిరీస్. ఓకే, ఫిబొనాసీ సిరీస్ ఇదే చూడ. నేను కూడా ఉన్నట్టు టక్కని కనుక్కోలేకపోయినా. ఓకే, ది ఫిబొనాసీ సిరీస్ కెన్ బి రిప్రజెంటెడ్ బై ద గివెన్ ఫాలోయింగ్ f of n minus 1 plus f of n minus 2. ఫస్ట్ ఒక రెండు నెంబర్లు ఆ ముందర దాంతో యాడ్ చేసుకుంటూ పోవాలి. ఫస్ట్ టైం వచ్చేసి n వచ్చేసి 0, సెకండ్ టైం n వచ్చేసి 1. ఇఫ్ n is equals to 0 or n is equals to 1. The Fibonacci sequence of the following series is 0, 1, 2, 3, 5, 8, 13, 21, 34, 55, 89, 144, 233, 377 and 610. Okay. తర్వాత Dijkstra algorithm is used to calculate the routing tables. Okay. Dijkstra algorithm finds the shortest paths from the source to all other nodes in the graph. Routing table maintains the shortest path, so Dijkstra algorithm is used to calculate the routing tables on the network. Computer networks కూడా వాడతారు అనుకుంటా. Which of the following algorithm design techniques is used to finding all pairs of shortest distance in a graph? డైనమిక్ ప్రోగ్రామింగ్ యూజ్ చేసి అన్ని షార్టెస్ట్ డిస్టెన్స్ కనుక్కుంటాం గ్రాఫ్లో. because Floody Warshall algorithm dynamic programming is used to find all the shortest paths between every pair of vertices in a given edge weighted directed graph. Dijkstra algorithm greedy could be used to find all pairs shortest path run from each vertex, but its time complexity will be more than Floody Warshall algorithm. Dijkstra does not work for a negative weight edges, and we can avoid calculating the same thing over again in a Floody algorithm. So option C is less appropriate. Backtracking time algorithm by tracking time complexity will be very high, so it is not feasible, and divide and conquer won't work for finding all pairs of shortest distance in a graph. Okay, dynamic programming anamata. Okay, problems 3 sat and 2 sat are NP complete and P respectively. Fourth, 3 sat problem is NP complete problem. 2 sat problem is being solved in a polynomial time, so it is complete under P problem. And fifth one, which of the following algorithm solves all pairs of shortest path algorithm? Floody Warshall algorithm. Fifth one, primes minimum spanning tree. Dijkstra algorithm single source shortest path for positive weighted edge. Bellman's Ford's algorithm single source shortest path for positive and negative weighted edge. Floody Warshall algorithm is based on dynamic paradigm approaches, which is used to solve all pairs of shortest problem. తర్వాత sixth one, time complexity of the computing the transitive closure of a binary relation on a set of n elements is known to be n cube. ఆన్సర్ వచ్చేసి n cube అనమాట. సిక్స్త్ దానికి ఎందుకంటే the binary relation can be represented by a matrix, and binary relation can be represented by the matrix, and Floody Warshall algorithm compute the transitive closure in n cube. తర్వాత సెవెంత్ వన్, let S be a NP complete problem, Q be a Q and R are the other two problems not known to be NP. Q is a polynomial time reducible to S, and S is a polynomial time reducible to R. Which of the following statements is true? R is a NP hard. And seventh one, an NP complete problem has to be in both NP and NP hard, but R is not NP, so R cannot be NP complete. So option A is incorrect. If NP hard problem is reducible to another problem in a polynomial time, then that problem is so NP hard, which means every NP problem can be reduced to this in polynomial time. NP complete problem, S is a polynomial time reducible to R, so R is a NP hard problem, so option B is correct. Now q is reduced to s in a polynomial time. If q is reducible to s in a polynomial time, q could be np, because np problems can be reduced to s, since q could be np, therefore q could be p also. P is a subset of np also. Q could be a npc, because every npc problem can be reduced to another npc problem in polynomial time, so nothing can be concluded about q. Eighth one, the following paradigm was can be used to find the solution of the problem in a minimum time. Given a set of non-negative integer and the value of k, determine if there is a subset of the given set with the sum equal to k. Dynamic programming. We need to determine if there is a subset of the given set of non-negative integer with the sum equal to the given value. This problem is a subset sum problem which utilize the dynamic programming methodology. Ninth one, the time complexity of a computing the transitive closure of a binary relation on a set of n elements known to be n cube. Okay. In a computer science, the concept of transitive closure can be thought of as a constructing a data structure and makes it possible to answer readability questions. The binary relation tells you only that node A is connected or not. Warshall algorithm can be applied to construct the transitive closure with complexity of O of n cube. 10th one. Consider the product of three matrices m1 and m2 and m3 having w rows and x columns, x rows and y columns, and y rows and z columns. Under what condition will it takes less time to compute the product as m1 m2 of the m3 than the compute m1 m2 and m3? 1 by x plus 1 by z less than 1 by w plus 1 by y. Okay. 10th one, m1 m2 and m3 of cost of calculating m1 m2 is w x y, and resultant matrix R will have w row and y column. Cost of calculating R m3 is w y z, and final matrix f1 will have w row and z column. Total cost is m1 m2 of m3 is equals to w xy plus w yz m1 of m2 and m3. Cost of calculating m2 m3 plus is xyz, and resultant matrix R2 will have x row and z call. Cost of calculating m1 R2 is wxz, and final matrices f2 will have w row and z column. Total cost is m1 m2 and m3, that is equals to xyz plus wxz. According to the question, m1 m2 of m3 will take less time than m1 m2 m1 of m2 and m3. wxyz plus wyz is less than xyz plus wxz. wxy plus wyz less than wyz plus wxyz. Dividing both sides with wxyz gives 1 by x plus 1 by z less than 1 by w plus 1 by y.